Take a look at integration of inverse trig functions. We're going to split it up into two videos, so go ahead and make a tab called inverse of trig functions. Alright, so do you remember derivatives of inverse trig? It's pretty much the same thing, so I'm just going to quickly remind you. So you go back to that page and this is the steps. I'm going to derive these formulas again because I think it's good practice, but you really need to memorize them. So if you have y equals the inverse sine of x, take sine of both sides, do implicit differentiation. So the derivative of sine is going to be cosine y dy with respect to y, and the derivative of x is just dx. And then go ahead and solve for dy dx. So dy is equal to dx over cosine y divided by dx. You're going to get dy dx is equal to 1 over cosine y. And we've done this before. Now that I have it in terms of cosine, think, what do you need? What formula do you know? What trig identity do you know with cosine and sine? Well, I know that sine squared plus cosine squared equals 1. So cosine squared equals 1 minus sine squared, and then take the square root. So you're going to get cosine is equal to the square root of 1 minus sine squared. So now we're going to replace cosine y with square root of 1 minus sine squared. And remember, x is equal to sine y, so we can rewrite that further and say dy dx is equal to the square root of 1 minus x squared. Listening check. Underline, remember derivatives of inverse trig. Exact same thing with respect to dx is equal to the inverse sine of x plus some constant c. Alright, so we're going to write a general form that we're going to pretty much be using. So instead of using x's, because it gets confusing, I'm going to use u's. And I'm going to use, instead of 1, I'm going to use a squared. So 1 over the square root of a squared minus u squared du is equal to arc sine of u, which is the same as the inverse sine. I just sometimes get confused with a -1 to think it's 1 over sine. So I like to use arc sine. And remember, because this is inverse, the domain is restricted to where u squared is less than 1, because you can't take the square root of a negative number. Alright, let's take a look at tan, the inverse of tan. So again, we've done all this before, but I'm just refreshing your mind. Take tan of both sides. The derivative of tan is secant squared y dy, and the derivative of x is just dx. Alright, so then divide both sides by secant squared y and divide by dx. That's what you get. And then what do you know with secant and tan? Well, you know the trig identity right above. So that's going to be 1 over tan squared y plus 1, which, remember, tan y is x, so that's x squared plus 1. Alright, so what we're saying is the integral of that 1 over x squared. So I'm going to write the general form. So let's say 1 over a squared plus u squared with respect to du. So a squared is going to represent the number and u is going to represent the variable. It's going to be arc tan u plus c. And on this one, there's no restriction because there's no square root. Let's take a look at another one. So these are the three most popular, the ones that you probably asked. So take secant of both sides, take the derivative of that. Alright, solve for dy dx. Alright, what do you know with secant and tan? Again, the trig identity you know is tan squared plus 1 is secant squared. You need to solve for tan because we have secant y equals x, so solve for tan. So tan squared is equal to secant squared minus 1. So tan is equal to the square root of secant squared minus 1. Alright, now let's go ahead and substitute that in. So we have 1 over secant y, and then now tan y becomes the square root of secant squared y minus 1. Secant y is x, so we can say that's 1 over x, and then square root of secant squared should be x squared minus 1. Alright, so the general rule for this one is the integral of that, so the integral of u, and we're going to use absolute value of u, and the square root of u squared minus 1 over 1 with respect to the u is equal to arc secant u plus c. And we do have a restriction here. The domain is for absolute value of u is greater than 1. Alright, so the key thing is once you know these three, you actually know the other three. So I remember that sine goes with cosine just because I remember derivatives and integration. So I always think sine goes with cosine. And all you're going to do in order to find the general formula for cosine, once you know the sine one, is just change the sign. So it's the exact same thing, just change the sign. This is a listening check. Circle the inverse of cosine. The inverse of cosine. So it's negative. So it's integral of negative 1 over the square root of a squared minus u squared du. And that's going to give you arc cosine u plus c. And again, for all u squared is less than 1. So basically the same thing, changing the sign. When I think of tan, I think tan goes with cotangent. Cotangent, right? Goes together. Alright, so all you do is you change the sign. So take the general formula for tan, just change the sign, and now you have the general formula for cotangent. So it's going to be the integral of negative 1 over a squared plus u squared with respect to du, and that's going to give you arc cotangent plus c. So listening check, color in, just change the sign. Just change the sign. Alright, last one, well, secant just goes with whatever is left, which is cosecant. So you see how they go together, secant, cosecant, tan, cotangent, sine, cosine. That's all you got to remember. So now all you got to do is just change the sign. So once you know the three, you really know the other three. And honestly, the three that I've gone over first are the ones that are most popular in AP. Alright, so minus 1 over the absolute value of u square root of u squared minus a squared with respect to du is equal to arc cosecant u plus c for all values of absolute value that are greater than 1. Alright, so let's take a look at an example, because you have to know these in order to do the work. So I would highly suggest that you pause this right now, go back, watch the video on derivatives, and then come back and do this. Alright, so I'm assuming you've done that. So let's take a look at how we do these questions. Alright, go ahead and pause the video and copy all that down. Alright, step A, substitute u. The denominator polynomial? No. So ask which one does this most resemble. So look at the different ones. Does it look like that? No, because that has a square root. Does it look like that? Possibly. So I think it looks like this. We're going to use this. So I'm going to write that down. So the integral of 1 over a squared plus u squared du is equal to arctan of u plus c. And the key thing is to make it look like this. So factor out the denominator if a is not equal to 1, which it is. So rewrite as a squared term. So you know that u squared is 16x squared. Then u has to be 4x because why? We're taking the square root of both sides. Alright, and then a, which is just the number 1, is equal to a squared is equal to 1. So take the square root of both sides, and a is equal to 1. So a is equal to 1, I don't have to worry about factoring out the denominator. So I can jump right into rewriting as square term. So we're going to rewrite that as a square term. So it's going to be the integral of, we've got a squared, which is 1 squared, plus u squared, which is 4x squared. And that's going to be 20 dx. Alright, so now let's find du in terms of dx and make it look like what I need. So du, so the derivative of u is going to be 4 dx. So that means I need it to be 20 dx though. So what do I need to do? To multiply both sides by 5. If I multiply both sides by 5, I get 5 du is equal to 20 dx, which is what I need. So now I can rewrite this whole problem in terms of u's and du. So the integral of 20 dx is going to become 5 du. So I'm going to put the 5 outside, du over, and then 1 squared, which is just 1, plus 4x is what? U. So that's u squared. So you can see now that that looks just like that. So once it looks just the same, I can rewrite what it is. I can actually integrate it. So that's going to be 5. And the integral of that is going to be arctan of u, which is what? What's u? 4x plus c. So 5 arctan of 4x plus c. And that's all there is to it. So once you know the shortcut, it's so quick. You need to learn them. So let's practice.